Hey, what's going on, guys? It's Adam here and welcome back to another video where today we're going to be talking about the brand new Mars rover that NASA launched to Mars on July 30th, 2020, Perseverance. Now in this video we're going to be covering the instruments and what they do and how they worked. I will put timestamps down below, so just in case you want to check out a specific thing, you can go straight to that portion of the video. Now, let's begin. Now first we have Mastcam-Z. Now this instrument is a camera based on the name cam, and it's located on the mast, or like the pylon looking thing on the body of the rover. Now its job is to take 3D images and look for signs of life, not at a microscopic level, but at a more broader level, scanning the landscape, and this is going to be the camera that takes main pictures of the Martian landscape. It has a 2 megapixel resolution, which for another planet is good, but for smartphones or any other sort of sensor, not the best, coming at a 1600 by 1200 resolution, and it's just supposed to be main photos taken of the Martian land. Now 5 things to know about Mastcam-Z. It looks for certain rocks that might contain life, learns more about the surrounding Martian terrain, looks for ancient signs of water, has a powerful zoom camera, and can see 360 degrees all in color. Now the name for this came from, well, what I said earlier. It's on a mast, it has a powerful camera system, and the Z stands for zoom. Next up, we have MEDA, the Mars Environmental Dynamic Analyzer. Now, it is located on the mast and a little bit on the body, and this is basically the Martian meteorologist. It determines the temperature on the planet, the wind speed, the surrounding humidity, even the size of the dust particles that blow around in the wind. So it's basically a meteorologist on the other planet. Now 5 things to know about this one is it learns how dust affects the atmosphere, helps predict weather for future missions, measures the radiation on the planet, how water vapor is exchanged between the soil and the air, and how will it affect performance for Perseverance in the long run. Because as we all remember, Opportunity a long time ago sent its famous last message, which I will put on screen right now, and we haven't heard from it since. Next up, we have Project MOXIE, the Mars Oxygen In Situ Resources Utilization Experiment. In other words, we're basically trying to make oxygen on the other planet. Now, Project MOXIE works basically like a tree does down on Earth. It takes in carbon dioxide and exhales oxygen. However, it's such on a small scale, it's barely even noticeable, producing a measly 0.0116 grams an hour. Now 5 things to know about this one is that oxygen is only 0.13% of the atmosphere in Mars compared to 21% in Earth's. So this is going to be used to help create and hopefully create a sustainable air supply for the planet. It's a test model the size of a car battery. To support life, it's going to have to be 100 times larger, if not bigger. 3, it's going to help human explorers in the future when we get there come back to Earth because we need oxygen to power the rockets. 4, as I said, it works like a tree. 5, homemade liquid oxygen could supply propellant needed for exploration not only on the planet, but again, to come back. Now here's how Project MOXIE got its name. It's on Mars trying to create oxygen in situ, which means in place, and it's an experiment. MOXIE. Next up is Project PIXL, the planetary instrument for X-ray lithochemistry. Quite the mouthful, but that is acronized as PIXL. This project uses an X-ray at the microscopic level to determine if there's any organics in the ground that could sustain life. So far, there's carbon on Mars, which is needed for life, but we're looking for smaller details. This X-ray can see things the size of a grain of salt, which is extremely tiny, and on another planet could be the game changer that could help us know that we can live on there safely. It seeks the changes in texture. By looking at the rock and the rock structure, it can look at the different changes to see if there has been signs of water or any microbial life. 2, small but powerful on the tip of the arm, but it's extremely powerful. 3, it's as easy to move as a pencil with paper. It has plenty of movement. It can see details the size of a grain of salt, as I stated earlier, and it can detect over 20 chemical fingerprints, which basically can help us trace back if there's any sort of element that can sustain life. It was named after a PIXL. The PIXL on the phone that you're watching this video on, or a computer. I don't know who names these projects at NASA, but oh well. Next we're on to RIMFAX, the radar images for Mars's subsurface experiment, otherwise known as RIMFAX. Now this uses powerful radar to go underneath the Martian planet and explore geological structures such as caves or possible frozen bodies of ice that may have accumulated since Mars is so cold. The last two. Next up, we have Project SHERLOC, the scanning habitable environments with Raman luminescence for organics and chemicals. Yeah. This camera system is mounted on the arm, again, of Perseverance, kind of like the other one that we saw earlier, PIXL. However, this one goes down even smaller. Top 5 things to know about this one. It works at the day or night, unlike the other one, and that has to work during the day. It goes 2 inches above the target with no contact needed, unlike PIXL. And it has a magnifying glass. Yes, this project was named after Sherlock Holmes and his magnifying glass. However, this magnifying glass is very powerful. It has ultraviolet laser light to spot organic chemicals, again, down to the micrometer, and has small pieces of spacesuit material on it to show how they hold up on the Martian environment with no one there. Last but not least, we have SuperCam. And yes, it's a camera. We have SuperCam mounted on the top of Curiosity on the mount. It is a camera with super zoom. It uses cameras, lasers, and spectrometers to detect any sort of organic compounds or any signs of life. As you can see, every rover that we send to Mars is really based around cameras and can we find life, which we might find with Perseverance considering how advanced this Mars is. Anyway, back to SuperCam. Its main job is to identify chemical compositions using that camera that you see on your screen right now, and it will go so far as including their atomic and molecular makeup, which is insane. Number 1. It works from more than 20 feet away using its superfine laser to study rocks smaller than the size of the tip of a pencil, which is very small. 2. It looks at rocks and textures and chemicals to find those that have formed or changed with water on Mars. It looks for different rocks and soil types that might include microbial life. It looks for potential hazards to humans that we may not know of. And it learns about the atmospheric molecules, water, ice, and dust that is absorbed or reflected due to solar radiation. So overall, this camera does it all. So that's all the instruments that are found on the Curiosity rover. This rover is jam-packed with a lot of different cameras and a lot of different sensors that could help us one day be able to live on there. But for now, it does a great job researching and giving us the intel that we need to be able to actually go and live on the planet one day. However, there is a lot more to this rover and entire mission than just the instruments that I have talked about in this video. If you want to see another possible part 2 video talking about other things, let me know down in the comments below. If you like this video, then make sure to hit the like button and subscribe if you're new here, and don't forget to ring the little bell so you never miss out on a new video when it's posted. That's all for this one. I will see you in the next one.